Hello, my name is Caitlin Schmidt, and I'm a traveling science show presenter here at the Franklin Institute. Today, I'd like to talk to you about how we could make an instrument using fire. So all sound, any sound you can think of, starts with something vibrating. Those vibrations produce sound waves. So I have a steel pipe here with a metal screen on the inside. If I heat that screen up and turn it, I get a sound. So how in the world does this work? Well, this actually involves a lot of physics. See, there are two main things going on here. One is something called Boyle's law, which you might have heard as the ideal gas law. This law says that as the temperature of something increases, like air, the pressure will also increase. So as I increase the temperature inside the tube by heating up the metal screen with a blowtorch, the pressure inside the tube is also increased. This forces the air outwards. So as soon as the air inside the tube comes out, hits the atmospheric air, it's actually reflected back inward. We get a standing pressure wave. We get different areas of high and low pressure, and this is the definition of a sound wave. Now, what's also going on here is something called convection. You might have heard of the term heat rises. What that's actually saying is hot air rises. So as I heat up the metal screen inside here, it heats up the air that's right around it. That air starts moving upwards, which draws in more cold air, which hits that screen, gets hot, and rises up. So we're not just getting one wave inside here. We're actually getting hundreds of waves. And waves, just like numbers, can add and subtract. And what's cool about these waves is they're all adding to produce one complete standing wave. It only makes a sound if I hold the tube upwards. As soon as I turn it to the side, that air can't move up and our wave is gone. What's really cool though is we could actually make an instrument out of this. So in order to change the note, you need to change the length of your wave. In other words, change the length of your pipe, which means the shorter something is, the higher the pitch will go. Once again, this has been Caitlin Schmidt from the Franklin Institute. Thank you guys so much, and check out our latest Spark of Science videos.